In this video, we're going to talk about the distributive property. So I have this going to set up in two different kind of examples. One to show you kind of like the big picture of distributive property, and then some examples to go forward. So we're going to first look at this rectangle right here, and you'll notice I have it just color coded. So I have this red rectangle that has, and I just counted the number of squares. It says 4 on the bottom and 3 on the top. And then I have this blue rectangle that's 2 on the bottom and 3 on the top. Okay, so if I was to ask you, can you take this red rectangle and tell me what the area is? Well, I know that it's 3 on the top. This number right here is the same as this number right here. And I want to find the area of this, so I'm going to multiply these together. 3 times 4, because remember, area of a rectangle is equal to length times width. So I'm going to multiply them together. 3 times 4 gives me 12. And I'm going to multiply together the area of this blue rectangle. So this blue rectangle is 2 by 3, and 2 times 3 is equal to 6. So if I wanted to know how much this whole big rectangle is, I'd add them together. 12, well here I'm going to actually write it like this. We said it was 3 times 4 and 3 times 2, which we said this was 12 and 6, and we add them all together and we get 18. Okay, so the distributive property without drawing a rectangle is doing the exact same thing, except now we're going to write it like this. I have this number 3 that I'm going to multiply by everything inside the parentheses, or which would be, in this case, the whole width of my rectangle. So what did I do? When I did this, I took 3 and I multiplied it by 4, which is right here. And then I took 3 and I multiplied it by 2, which is right here. So when I'm writing out the distributive property, I'm going to take 3 and I'm going to multiply it by 4. And I'm going to take 3 and I'm going to multiply it by 2. So I'm going to write it out. 3 times 4. And this sign right here in the middle, here, this plus right here, it stays the same because this is a positive 3 and a positive 2. Plus 3 times 2. Okay, so now we multiply using order of operations. Order of operations says I'm going to multiply first before I do adding. So I have to first multiply 3 times 4, which is 12, and then multiply 3 times 2, which is 6. And then I combine them together, which is 18. You'll notice all of this work is exactly the same. So I took this distributive property problem and I made it into a basically an area problem where I'm multiplying and finding the area of rectangles. So let's do another one, except now we're going to introduce a variable. Okay, so this one here, I have x and 4 on the bottom and a 3, x and a 4 on the bottom and a 3 for my side. Okay, so if I was to find the area of this green, I would take x3 times x, which would give me 3x. I'm going to write it out, 3 times x. And then this pink guy, I would do 3 times 4, because I'm taking my two sides and I'm multiplying them length times width. 3 times 4 is equal to 12. So if I look at my math problem, I have 3 times x plus 3 times 4. 3 times x, we already did the math, is 3x, and 3 times 4 is 12. And that's it. In my last step, I could take them here, 12 plus 6, and I can combine them together because they're like terms. They're both constants. But here, I have 3x and 12. This guy has x's. This one does not. So here's an x, and then this is a constant. Because these are different, they're not like terms, this would be my final answer. So now, if I'm not writing it as an area problem and I'm writing it as the way that most distributive property is written, or most math you're going to see, I'm going to take this 3, I'm going to multiply it by everything inside. 3 times x and 3 times 4. So I write 3 times x and 3 times 4. 3 times x is 3x, and 3 times 4 is 12, and I end up with the same answer. Now, if you happen to like kind of like this whole area problem, you can kind of write it out a different way. Let me show you really fast how to do that. I'm going to just shrink this down and kind of move it over here. If I wanted to write this problem out, I can do it like this. I can write a 3 on the one side, and then I'm multiplying x plus 4 like this. So then you kind of trace your finger. You say, okay, in this box here, in this yellow box right here, the yellow box is made up of a 3 and an x. So I would multiply these together. 3 times x is 3x. In this green box right here, okay, it's made up of a 3, and a 4. So I would multiply those together. 3 times 4 gives me 12. So, and add these guys together here gives me 3x plus 12. That's just another way to write out the distributive property. It's kind of like the area of a rectangle, and it's like a combination of the area of the rectangle and just writing out like the traditional method. So you can pick any of the ways that you want to do it, as long as you understand that you're just multiplying the number on the outside by everything on the inside. So I got a couple practice problems for you to try. So we got -2 times, and we say this, the quantity y plus 5, and -7w times the quantity w minus 5. Go ahead, this is a good time to pause the video right now and try these on your own, and I'm going to go ahead and work out the solutions. So in -2 times the quantity y plus 5, I'm going to make sure I take this -2 and I'm going to multiply it by everything on the inside. So I have -2 times y is -2y. And a -2 times a positive 5, remember a negative times a positive is a negative, and you can either write it plus a negative, and 2 times 5 is 10, or you could write it minus 10. You're typically going to see it written this way in most math books. Most math books and ways that you write problems are going to traditionally write the subtraction, but it is not wrong if you write plus a negative. It means exactly the same thing. Okay, so this is your final answer here. And this next one here. Now you want to be careful with this negative out in front and this second negative term right here, because this is where a lot of mistakes are made. So I'm going to distribute. I'm going to multiply by everything. Okay, so I have -7w times w gives me -7w times w is w squared. And -7w times a -5. Remember, a negative times a negative is a positive, so this is going to change the sign to a positive. And 7 times 5 is 35w. So, and now I have to look, are these like terms? Here I have a w squared, and here I have a w. So because my one w is squared and the other one is not, they are not like terms. So this would be my final answer. Let me know if you have any questions. Good luck.